Let's start this. Let's open it. Hi and good evening, everybody. Welcome to our broadcast session today. We are jointly together, Power BI user group Hamburg, Stuttgart, and Cologne. First joint event, and we are started this today together because we are having Marco Russo here, which he will present us his topic about performance optimization. And just to welcome our my co-hosts, Lars Schreiber and Philip Lenz. Hi guys, so most of you in the community knows them as leaders of Power BI user groups in Hamburg and Cologne. I'm a user group leader from Stuttgart. And so we have quite a lot of things today. Marco will guide us through. But first, let's just jump in upcoming events we have. So it will be an action-packed spring in German user groups. So you will see here lots of presentations that will go on in April and May. Also, you can look for all the details on meetups in the meetup groups of Stuttgart, Köln, and Hamburg will probably come in. And not to take too much time, not to bother you with all the details, I will hand over and welcome our guest for today and let him do his show. Marco, stage is yours. Marco, I think you're on mute.
Hello, can you hear me now?
Yes.
Okay, sorry, I didn't realize I was in mute. So, good evening. My name is Marco Russo. I'm here today to talk about Power BI report performance. And the title of the session basically explains my goal, which is provide you a guidance about what are the first thing to do when you have a slow report and you want to investigate about the reasons why the report is slow. So before we start, I have just one slide here. I work at SQL BI, where we produce content about DAX and Power BI, tabular modeling. You can find a lot of articles, videos. Most of them are free. And of course, we also sell training and consulting. You can find everything on our website. What we are going to do today, we are going to describe what to inspect when there is a performance issue in your report. What are the most common reasons why something is low, especially when you refresh the report, when you navigate into the report. We don't analyze what if the report is low to be refreshed. And I will focus mainly on importing data. If you have direct query that is low, it's just because your database is slow, but if you want performance, you have to import data. So I know many people want to use direct query, but don't pretend direct query to be as fast as imported data. It's simply impossible. In this QR code, you can download the same sample file I will show you during the demo. Even though it is not important, you can actually follow through just watching what I do, and then you can try the same tools and the same actions on your model if you have something slow. So I have a few slides that I will use just as a recap. It's better we spend time now on the demo. And the starting point is a dashboard I prepared, which is a single page report in Power BI, which display a lot of numbers. Basically, it's just a measure displayed in a card visual. You see that each card here has a different selection of filters. So if I look at the filter for each visual, you see that the filter is different. I have a different brand And I have a single measure here. In this case, the measure is the measure here, sales amount, sorry, red sales in this case, which is displaying simple sales amount filtered by red color. So we have a filter is applied to the measure and a filter is applied to the visual. But because we have so many visuals, what's the problem? What is the performance issue here? Well, look at what happens when I, for example, click on a bar chart here. I click on North America. When I click here, you see that it takes a few seconds before we see everything updated. And if I click on Europe, again, I wait a few seconds before all the numbers are updated. The following times, this is fast, but just because once you have used a certain combination of filters in your report, when you recall the same combinations of filter, there are no new queries. Basically, Power BI reused the previous result of the query to display the result. And for this reason, it's so fast. Now, in reality, there is also another problem here, which is not very visible, because also the visualization here, this matrix that I can expand to a longer list here, is relatively slow. But if you took a look at what was happening when I was refreshing this slide, this report, I was waiting a few seconds just because there are too many visuals. So the first thing we have to do is understanding whether we have too many visuals in the report. The first tool I want to show you is the tool we have here, which is called Performance Analyzer. When you click this button here, Performance Analyzer opens this pane. Let me close a few other things so we have more real estate available. And when you click on Start Recording here, you start capturing events of what happens in your user interface. For example, if I click on Asia here, you see that there is an event that is cross-highlighted, or when you click on a slicer, you see the slicer selection, and then you have a long list of lines here. Let me, sorry, I forgot to open that Zoom it, that I think is better if I have it. Give me 1 second. I want to open the tool to highlight a part of the screen. This one coming soon. Here we go. And here we go. Okay. So you see here we have this list of elements, and each line represents one visual. This is one visual, this is one visual, and so on. And here you see how much time we waited for that visual to be completed. Now, if you look at these numbers, every visual took thousands of milliseconds, which means a few seconds, but clearly we didn't wait for minutes. So the problem here is that every visual shows the waiting time for the visual, but when we have many visuals in the report, this is not the time that we can accumulate. Let me see if I can get rid of this. Okay. What does it mean? If you think for a moment, let me go to the slide 1 second, and let's try to draw this. So if I clear this white screen here. So the idea is the following. If we have, oops, I don't know why it didn't work. So let me try again. I wanted to drive in, I wanted to draw in the screen. Let's see if I can wide the screen and use the pen. Okay, so let's see if this works. Okay, so this is the time, and in my report I had one visual, another visual, another visual, another visual. Now, if all the visuals were displayed at the same time, they will be executed in parallel. But this is not what happens. what happens is that if this is time zero is when I click on a slicer or I click on a chart, and this action starts the refresh of all the visuals. These visuals are created and updated in groups. Let's say that we have 2 visuals at a time. You can imagine something like this happens. So in other words, if I want to analyze how much time I spent waiting for this visual, I always start from 0, but then I compute the time to reach this point. So this is the delta time that I'm measuring. And this delta time is made by the time required to refresh the visual, which is, let me change the color, which is this time. So this is the time I really consumed for this visual, but I have this other time that is waiting time for other visuals, right? So when you have many visuals, only a few visuals can be displayed at the same time, but the other have to wait for the others, for the other visuals. If I remember well, Power BI displays up to 4 visuals at a time, which means that if you have 40 visuals, you have, like 10 batches to compute. It's more complex than that, but I'm trying to simplify. The reason why I'm showing you this is because if I go here and I go back to the, if I go back here to the list of the visuals, I can expand here and see for each visual what, how the time was spent. And as you see, this visual I waited this visual for 1.5 seconds, but in reality, the visual was not consuming much time. In a moment, I will describe what these 2 lines are, but this other is the time to wait for other visuals. And in the previous chart, I was displaying in a more, useful way. Here, we don't have this data sorted in a meaningful way. And so this other time is not really easy to understand because it depends on some other visual. If you open all the visuals, you will see that this other time is larger for some visual, but some visual will have close to 0 because it's the first visual to be produced. So what we can really do in order to optimize the visualization is, first, we can try to reduce the number of visuals. Because if I reduce the number of visuals, I don't have this waiting time, and I reduce the list of visuals that have to be displayed. Moreover, every visual has to send a DAX query to the engine, because the visual displays a number here, but this number is the result of a DAX query executed on the DAX engine, on the Tabular engine where we have our data. The result of this query is then displayed by the visual. That in this case, the car that I'm using is showing the number with a certain text here and a color. But if you have a chart, you will see the chart. If you have a map, there will be points in the map and so on. And the visualization, the visual display is basically the rendering of the of the numbers that you have. And this could be more expensive if you have many data points and a complex visualization. In a card with a single number, I expect this number to be very small. But when I have a map with thousands of points, I expect this number to be larger. This DAX time is where we spend time waiting for the data to come back from the engine. And if we write a slow measure in DAX, this is the number we will see that is large. So now if I sort these numbers, you see that I can sort in a descending way the action order or the total time, the total execution time. If I look at the total execution time, it seems that the slowest visual was this one. But as you see, this visual is a quick visual because I waited only 7 milliseconds for the DAX query and 24 milliseconds for the visual display. These are absolutely small numbers. If I waited 5 seconds, it's just because in my entire report, I have so many visuals, and each visual has to create a query, send a query, get the result, display the render, and this takes time, just waiting time. So the first optimization I can do to this visual is trying to reduce the number of visual elements I have. So if instead of creating so many visuals, each one to display a single number, I find another way to represent the same information, reducing the number of visuals, and so reducing the number of queries and a number of actions to update the report, I will optimize my report. So the first optimization I can do here is, for example, the following. So let me show you this visual here. Each number here is a different visual, which is the card visual, the standard card visual we have here. As you see, I loaded from the marketplace a free visual, a free custom visual called card with states. And I use card with states in this other page. You see that this is the same visualization, but what is the difference? When I click here, these bars, these tiles are combined in a single visualization, which means that here I have one measure, which is always my red sales measure. You see here measure red sales, but I have a visualization of this measure split by category, and the number of tiles required are automatically generated by this visual. Why this is faster? Let's try. If I go in Performance Analyzer, you see that when you want to measure the performance, you can also click here, Refresh Visuals, and this forces a refresh of all the visuals you have in the page. And you see that the entire report that basically shows the same information we have seen before is made by less than 2, 4, 6, 8, 10 visuals. Before we had almost 30, 40 visuals. So by just reducing the number of visuals, I have a faster execution time. Indeed, if I click here on North America, you see that I click here and bang, I already see the result in 1 second or something like that. Actually, each visual that displays many numbers has a shorter waiting time, 642 milliseconds. And if you look at the visual display is taking more time. We have 230 milliseconds instead of 10, 20 milliseconds. But because we reduce the number of visuals, even though the visual internally displays more numbers and more elements, it's more expensive, but overall I'm saving time. I'm saving time because I'm saving this other time, and I'm also reducing the number of queries to be executed, and there is always some latency waiting for the result of each DAX query. So overall, I'm improving the performance. And this was my first optimization. I didn't change anything in DAX in my measures. I just reduced the number of visuals to display the same information. Now, am I suggesting you have to use the custom visuals? No, this is just an option. You could have obtained the same result, even though not with the same layout, by using a table or a matrix, by combining the data in a different way. So you might try to arrange the visualization so that you reduce the number of visuals, also reducing those just decorative visuals like lines, small bars, or simply graphical effects. Just create a single bitmap as a background and remove all the additional visuals that are just for decorative reasons, because they takes time to be rendered. Now that we did this first optimization, so let me go back to the slide 1 second, just to recap what we have seen so far. I introduced Power BI Performance Analyzer, which is the first tool we use when we want to analyze the performance. And this tool, sorry, I made a mistake here. And this tool can show me the list of the actions and following visual updates that occurred in your page. And you can arrange the sort order by choosing to sort the visuals by action order, by total execution time, or by DAX query execution time, which is the next thing I will do. Because once I made this first optimization, I could discover that there is something else I can do to optimize my visual. Because if I look at the data we have now, you see that we have these visuals are relatively quick. But there is this matrix here, which is relatively expensive. It's 2 seconds. In my initial visualization, something that was 2 seconds was not the slowest part of the visual because I waited for 5 seconds just for a few visuals. But here, this is now the slowest visual in the entire report, and the DAX query time is almost 2 seconds. So there is something wrong in my measure because I know that this model is small and it's unreasonable. I have to wait 2 seconds for a DAX calculation that is simply a sum of sales for a color. Oh, sorry, we will see. No, this is not the sum of sales, but the size of my model is not that big. The sales table here has, sorry, not this key. Here we go. Okay, here in this corner, you see that the table sales has just 10,000 rows. It's a small table. It's a small table. It's not a big table here. So we don't have a lot of data. Why I'm waiting 2 seconds? I expect 2 seconds when I have a few million rows, maybe tens of million rows, but not when I have 10,000 rows. So now I want to investigate about what is going on. And in this case, how can I investigate trying to figure out why this is so slow? So you see that this button here, copy query, copy in the clipboard the content of the DAX query that has been executed to populate this visual. You see that when you click a visual, the same visual is highlighted here, so we can see that the matrix we are referencing here is actually this matrix that I can also enlarge here. And you see that this matrix is showing for each product the value of the sales amount of the product and the number of unique customers who bought that product. So there are 2 measures here, sales amount and customers. And if you go in the definition of the 2 measures here, sales amount is this simple calculation, sum sales multiplying quantity and net price for each row, plus 0 to remove the blank. And here, number of customers is calculate that performs a distinct count of customer key in the sales table, featuring the sales quantity that has to be greater than 0. We want to ignore transactions where the quantity could be negative because maybe that we made a refund or something like that. Okay, so let's try to see what can I do. So at this point, I introduced another tool, which is DAX Studio. DAX Studio is a tool that you can launch from the external tools ribbon if you already installed DAX Studio in your machine. Now, DAX Studio, if I go to the slide 1 second, DAX Studio is a tool, an open source free tool you can download from this link. Let me just open. I'm not able to open. Where is the mouse here? Come on. I lost my mouse. I don't. Okay, so let me. Let's open here daxstudio.org and move the window here. So you can see this is the web page, and from this button you can download and install DAX Studio. Then you can also access to the source code, and if you cannot install, you are not an administrator, you can download the zip file with just the executable you can copy and launch on your machine. But in that case, if you cannot run the installer, you will not see the ribbon external tools here, and you have to launch DAX Studio as a separate tool. Now, when you launch DAX Studio from within Power BI, what happens is that this tool appears here and is automatically connected to the model, to the same model where we have the data in Power BI. You see that here I have the same list of tables that you can see here, customer, date, product, sales. And if I open sales, I have exactly the same measures and columns. And when I browse here, you see also some additional information like the number of unique values you have in each column, the number of rows in a table, and other statistical information. Now, DAX Studio is a tool to write and run DAX queries. For example, if I write evaluate followed by the name of, for example, all customer education. So I'm writing a DAX expression, which is like in SQL, it would be select star, select listing education from customer, something like that. And here you can see the result of a DAX query. Now, in order to use to write DAX code, you have to know the syntax of DAX queries, or you could use the query builder here, which is a tool to drag and drop columns. For example, I could use the brand and the color and the sales amount, and I can click run and I can see the result, but I can also click on edit query and I can see the DAX code that has been automatically generated by the query builder for me. Now, so DAX Studio can do many things, but in our case, what we want to do, if you remember, I copied in a clipboard the content of the DAX query that was used to populate the matrix. And if I paste the code here, this is the code that was executed to populate the matrix. Now, I don't enter now into describing the code. I want just to show you that if I click run, I execute this code, and this is the result that was sent to the visual, that then rendered this content using the right format string, the right name of the column, maybe placing a total at the end, and so on. But you can see that this is the same content we have seen here. It's the same thing. Now, sometimes you could see a different representation. In this case, the representation is very similar. It's still a table, but when you have a chart, you still have a table as a result of a DAX query, and then the table with these numbers is combined into a line chart or into something else. But why is it important to be able to run DAX code here? Well, there are many reasons. One reason is that I could just test my code. I could test the correctness of a formula. For example, here we have both sales amount and customers. What does it mean? Well, let's take a look at this. Sales amount. Sales amount is a measure that I have here. And if I right-click this measure and I click on this define measure, I include in the definition of the query a copy of the definition of the measure. This syntax in DAX allows you to create a local version of the measure that you can modify, and this version of the measure sales amount replaces the definition we have in our Power BI model. For example, if I multiply the number by 100 and I run this query again, you will see that the numbers here have been multiplied by 100. Let's add other 2 zeros, and you see that the number is always bigger, right? So actually, I can try a different implementation of my DAX formula just to see whether the number is correct or not, without actually changing anything on my model. This is very useful to, debug your measures. Another thing we can do, we can activate server timings and query plan. You will see that these are 2 additional windows that are now created here. Now they are empty because I didn't run the query, but if I run this query again, I will see that this content is populated with statistics about the execution of this query. Here you have the query plan. The query plan in DAX is something that is not so easy to read. You don't have a graphical visualization of the query plan like you would have in a SQL Server query, for example. Usually the more interesting part is this server timings that shows how the query spent the time in the 2 parts of the engine, the formula engine and the storage engine. And the total execution time of this query was 249 milliseconds. And of this time, 88% was spent in the formula engine, 11% in the storage engine. However, when you test your code, you should do one thing. You should always test the code in the worst possible condition, which means I want to clear the cache and then run. I could do this manually. Clear the cache is a button that clears the storage engine cache, and run, simply run the code. But if I switch this mode in clear cache then run, every time I click this button or I press F5, I execute two operations. First, I clear the storage engine cache. Second, I execute the query. And as you see, in this second execution, now the query was taking 1.5 seconds, and 72% was spent in the storage engine. So the storage engine now is more expensive than before. And the idea, I want to see the worst possible condition because I want to optimize the code so that even though nobody ran this query before, I want to get the best possible performance if possible. Now, at this point, you have to start investigating in which measure is slow. You see that I have two measures. So first of all, do we have a slow performance because of the measure sales amount or because of the measure customers? You can simply comment out one of these measures and run this query again and see if something has the same performance. Now we have just to make a small change here because sales amount was also used here. So if I don't use sales amount here, let's say I use customers, it was used for the sort order. So sometimes you have to adapt the code so that you don't have references to something that you commented out. So if I run this query again, at this point, I have only the number of customers, and the server timing is actually very similar to the previous one. So I know that if I do the opposite, so if let me roll back to the initial version, here we go. Now, if I only comment out customers and I run this query again, you see that the execution time to get just the value of sales amount, not the number of customers, in this result, this query is very fast. This query is the right execution time. So in the worst possible condition is 10-16 milliseconds, which is very good. I would like to have a similar performance for the number of customers. So there is something wrong in the number of customers. And now I have to restore the code with the number of customers. I start this query again, and I see that it is running in 1 second. Now at this point, I have to know something about how to optimize DAX code. I can tell you that the engine, so I can go 1 second on the slide. So just to recap what we have seen so far. So we have seen a very, very quick tour of DAX Studio. And DAX Studio has the ability to also capture query or to analyze the queries that we capture with Performance Analyzer. Oh, there is a feature I forgot to mention that I will show you in a moment, which is Vertipack Analyzer. Because before looking at this feature, how can we say this is a large number or a small number? At the beginning, I said I have 10,000 rows in my sales table. My sales table is small. I don't expect this to be a slow query that requires seconds. But if I don't know the model, how can I retrieve this information? So here in advanced, you have this view metrics button. When you click on this button, there is another pane that is called Vertipack Analyzer Metrics that shows how big your model is, 2 megabytes, and other information, number of tables, columns, and so on. Now, 2 megabytes means that the model is small, but how the data is used in the different tables. And you see that for each table, I can see how many rows I have in each table and how much memory in bytes is required by each table. And when you drill down, you can see the cost split by columns, because the data in memory is stored by column, and the cost is always by column, because every column can have a different compression and every column can have different cost in memory. Because the columns involved in a query are always scanned by the engine entirely, the smaller the column, the faster the query. So when you have a column that has a column size of 1 gigabyte, in order to scan 1 gigabyte, you might expect 20, 30, 40 milliseconds. But if a column is just 1 megabyte, it should be much, much faster. So usually we use this information, the column size, to understand the cost to scan the memory for the engine. And the other important information is the cardinality. Many operations are slower if there are more unique values in a column. For example, in this case, I'm trying to do the distinct count of the customer key. If you remember the definition of the customers, let's find the customers measures here. The customers measure is defined using this distinct count over sales customer key. So sales customer key is the column customer key in sales, which is not that big and doesn't have too many unique values. But for example, if the customer key had 2 million of unique values and a size of a few gigabytes, I know that it's normal to wait 1 second. But this is a small column, so it's not normal to wait so much time. So if I go back to the, so this is the integration of Vertipack Analyzer in DAX Studio. I suggest you to take a look at the Vertipack Analyzer content, also because Vertipack Analyzer has more information that you can analyze, like the relationships you have in the model and the more details about the compression used for each column, which is useful if you have models that have hundreds of megabytes or more. When you have a small model with a few megabytes, usually you don't need anything more than what you have here. When you have a large model, gigabytes of data, you probably want to export the metrics and import them in the Excel file that Vertipack Analyzer provides. It's not the topic for today, but just to, something you might want to investigate more. So now I see, okay, so there is something strange because the distinct count of this column should not take so much. This column is small, the table is small. So what is going on? At this point, if I go back to, why this is showing, okay, so if I go back to the server timings here, I can investigate a little bit more in these numbers. And I see that, yes, the storage engine is where I spend most of the time. But I executed 458 queries in the storage engine. So the cost of each query in the storage engine was small. Indeed, the list of the queries in the storage engine is this list. Every line here is a different request that the formula engine made to the storage engine. So the formula engine calls the storage engine, gets the data back, then perform another call, and so on. And every call is taking only 1, 2, 3 milliseconds, which is absolutely good. But the problem is that the formula engine is calling the storage engine too many times. And this is the reason why we spend almost more than 1 second, because for 500 queries, we spent more than 2 milliseconds for each storage engine query, resulting in 1 second. Why is this happening? If you look at the code here, you see that every storage engine query is described in a language. This language is called XMSQL, which is similar to SQL, but is actually just a textual representation of an internal object model that requires data from the formula engine to the storage engine. And you see that these queries are very similar, but you have a select distinct count of this column from table sales, join product, join customer, everything is fine. But here there is a where condition that for each row shows a different list of products. What is happening? Actually, there is a list of product with another number here, which is the quantity and the continent. Why is this happening? Well, now the explanation requires, the technical explanation would be long, but I try to simplify. In this case, the problem is that my calculate statement wanted to compute this distinct count, filter in the quantity greater than 0. How did I write this filter? Using this technique, filter table sales. So what I'm saying is I want to get the table sales, 10,000 rows. I want to filter each of these rows, only considering those that have quantity greater than 0. Now, if there is something that is bad in a DAX formula, is filtering a table where you really just want to filter a column. My goal was to filter just the column quantity. My goal was saying, I want the quantity to be greater than 0. I don't actually want to filter the other columns in the sales table. However, I wrote the formula this way just because I can, but it's a bad idea. Don't write table filters in Calculate if you can. So if I get rid of this, I could have wrote the formula this way. But now I cannot just remove the filter, because if I wrote the filter and the formula was validated and right, the syntax equivalent predicate for the filter I wrote before requires keep filters. Because the way I wrote the filter before was inheriting the filters already applied to the sales table and was creating a new table filter over the entire sales table. By using keep filters, I obtain the same semantics, because otherwise, if I don't have keep filters, I override any existing filter on quantity. And so if the user had a slicer or saying, for example, quantity less than 2 or less than 3 in the report, I had to respect that filter. I was respecting this filter before, and I want to respect this filter now. I don't want to overwrite and get rid of that filter. And this is the reason why I have to write keep filters. Now, I rewrote the formula with a syntax that should produce exactly the same result. So look at the numbers, 144, 144, 46, 46. If I click run again, I expect to see the same numbers, because otherwise I made a mistake. And it worked. I click run and I have the same numbers, even though I changed the definition of customers. But if I go to server timings now, you see that this execution took only 12 milliseconds. Why? Because here we have a single storage engine request that is computing a distinct count of customer key for each product name, which is exactly what I want. One storage engine query, instead of just 2 or 3 milliseconds, now it takes 6 milliseconds because it has to compute the distinct count for many products, but there is a single request. The formula engine only waits for a single request, and in 12 milliseconds, the execution is completed. So if I go back, now that I know that this is the definition of the measure that works, I still have to fix the Power BI model. So I go back here in the definition of customers, I paste the code that I wrote and tested in DAX Studio. I click enter here. Then I go back to this visualization. Okay, let's go back to the report here. And what I can do now, I can try to clear this list and refresh the visuals. So in this new execution, you see that the matrix here took only 16 milliseconds. And now if you open all the visuals, you see that the slowest part of each visual is the other. And other is just the waiting time for the other visual. So remember, this other time is not that important. You could ignore it. And this is also a reason why we have the ability, if you have a very long list and this other is confusing you, one thing you can do, you can export this file. This file is exported as a JSON file. You see, I'm exporting this file performance, Power BI performance data.json. And what can I do with this file? In DAX Studio, I have another button here, which is load performance data. This load performance data can read this file and can show me the same information that you have seen in Performance Analyzer in Power BI in this other format. You see that for each visual, we have the time for each query. We only focus here on the DAX queries, of course. We don't have the rows with the visuals that don't have DAX queries. And you just have the query time, the render millisecond, which is the display time, and the total. In this case, the total is the sum of the query, DAX query, and the visual display. We ignore, in this visualization, we ignore the other time, which is just confusing because here I can see that the actual time spent for each visual, now the visuals are slow because we have hundreds of milliseconds just to render the content of the visual. But if you remember, this was an optimization we made before because the alternative was having too many visuals and a much longer waiting time. So, Vertipack Analyzer is the tool embedded in DAX Studio that allows you to understand how the data model, how big the data model is. And this is important to evaluate, am I executing something that is too slow or is good enough? And this is something that helps you understand this. We have seen that the query plan has a few information that are not so easy to decode. The logical query plan and physical query plan are displayed in a window, and another window shows you the Vertipack queries and the time spent between the formula engine and the storage engine, and usually it is more productive to focus just on that visualization. The formula engine understands DAX and NDX. The storage engine is a very, very simple but fast engine that actually retrieves the data from the in-memory storage engine, columnar-based storage engine. If you use if you use direct query, your storage engine queries will be the SQL code sent to your SQL server or to any other engine you have. At that point, I expect that the storage engine is more expensive and the latency is much bigger. So you probably start to look at the seconds time, not the milliseconds that I am worried when I use the Vertipack engine. Every storage engine query retrieves what we call a data cache, and this result is consumed by the formula engine. The result of the storage engine query consumed by the formula engine is uncompressed. So one other problem that you might face in your code is that the size of the result of the storage engine query is too large and part of the job is made by the formula engine. This could be another reason of slow performance. XMSQL is the language that we have seen in the description of the storage engine queries that we analyzed. The formula engine consumes the data caches. The same data cache can be consumed several times, but you have seen that the reason why we had a slow performance in the previous case was that we just had too many requests made by the formula engine to the storage engine. However, the reason for DAX performance issues are many. I just showed you the first quick example because my goal was to make a quick tour about what do you have as tools to investigate in the performance issues and understanding whether you have a visualization issue, a DAX issue, and what are the tools to analyze the DAX, the behavior of the DAX code. So when you have a performance issue, first check what is the visual that is lowest. Within the visual, check what is the measure that is lower compared to other measures. Create this query that reproduces the problem, so you narrow the problem to something smaller to analyze, and then you start testing your different implementation of the DAX expression for the measure and finding if you obtain better timing. What if you want to know more about how to optimize the DAX code? The book, The Definitive Guide to DAX, has several chapters just about how the engine works and how to optimize DAX code. There are 2 free white papers that are available on our website where we describe how to read the query plans that you have in the query plan pane. So if you are curious about this, you can also download these 2 white papers and study them. Tools, DAX Studio, Vertipack Analyzer, here are the links to get these tools, but I think they are very, very easy. You go on a search engine and you can find them. So I'm open to your questions. I didn't receive any questions so far, but I hope we have questions now.
So Marco, there was one question in the chat for now. So it was from Christian. Yep. What is the limit in seconds acceptable before starting to check DAX optimization? Is there a guideline for this?
It usually depends, but let's start saying, if you have a DAX query running in less than 100 milliseconds, usually I will not spend too much time because usually you have something that is much slower probably, right? Let's start saying this. When I refresh a Power BI report, I expect the result to be in 2-3 seconds, something like that. If I have to wait 10 seconds every time I click somewhere in my report, to me, the report is slow, period. I have to do something. It's not acceptable. The expectation in Power BI, you click on something and the feedback of your action is within 2 seconds, right? This is the expected result. When I have a feedback above 2 seconds, I can start thinking about doing something. Definitely, I will move doing something when I have more than 3, 4, 5 seconds. A very good model has, clicking on a slicer is just under 1 second. I say 2 seconds because, sometimes, you have the network, you have the latency, there could be something happening. So if you look just at the DAX code, I will not spend too much time when a single DAX query is below 100, 200 milliseconds. But when I have something that is above 1-2 seconds, I start to try to investigate. But there are queries that run in 2 seconds and are very good. So it depends, right? If I have a large matrix with 20 measures in a matrix and thousands of rows, if it takes 2 seconds, it's fine. It's fine because every measure is a different evaluation. So when you have too many measures in many columns that you cannot even read and you wait seconds, it's normal. Optimization, reduce the number of measures in a visualization, create another visualization for other measures. So split the work in different queries, because otherwise you wait for something that you don't even see and you don't even present to the user. And that could be another parameter. Okay.
So there is no more questions in the chat. Just you got a message. Grazie mille, Marco. That was a great presentation.
In Italian.
Yeah.
Okay.
So if there are additional questions, I call you all to pose them quickly so Marco can answer. So there is another one. So what needs to be checked first when a Power BI report is slow? Check the data model, local hidden time, date tables, cardinality on columns, or DAX.
Say it again, sorry.
So the question is, what needs to be checked first when a Power BI report is slow? So is it data model, hidden date tables, cardinality, or DAX itself?
I'm thinking. Let's say that. So when I open the, it depends. If I open a model I never seen before, okay, let's start from this. I don't know the data model. I never seen the data model before. What do I do? Okay, I open the model. I open Vertipack Analyzer. In DAX Studio, you can export the VPAX file. And when I do consulting, what I do, I ask, send me the VPAX file, because it's a small file that has only statistics about your model, doesn't have any data. When I look at the information in the Vertipack Analyzer, because I can open Vertipack Analyzer also in another DAX Studio instance, I take a look at the number of tables, not the number of tables, but yes, the size of the table. The cardinality is more important than the size to me. So I look at the tables because I want to see how many tables are, in the millions. Okay, any table that is 10,000, 20,000, 30,000, I don't care. I look at the tables that are relatively large. Once I realize how many tables are, relatively large, I look at the relationships and I check whether, I show you here, I go in Vertipack Analyzer matrix, I go in relationships, and here you see this max from cardinality, max to cardinality. Now I have only one table with a relationship, but when you have many tables with relationships, just looking at the table level, if the max from max to cardinality is above 1 million, is already something useful. And I also check whether there are relationships that are not one-to-many. So if I have relationships that are many or strange cardinality, that's another thing I want to immediately check. Because if I find something there, I know that I could take a look at the data model. If I see that even though I have large tables in the millions, the max from max to cardinality is never above 100,000, and I don't have bidirectional filters, I don't have many-to-many cardinality relationships, the model is hardly part of the problem. Okay, it could be, but usually it's not a problem. Whereas when I see that, oh, there is some expensive relationship, there is some bidirectional filter, wait a minute. Even though you have simple measure, we could have a problem in the data model. So at that point, I analyze the data model. So I will not say that there is something, but there are elements there are signals that suggest me to look at the data model first or look at the DAX code first. Sometimes the problem is the way the DAX code has been written. Sometimes the data model, sometimes both. It depends, right? But the hidden timetables, I mean, yes, but it's a very trivial problem. I mean, that is immediately visible. As soon as you open tables here and you see a lot of data table with a large table size, you know that you have a problem. But it's not so common. It's not so common. I mean, this is the type of problem that people don't call me for that problem. Usually they find it they find a problem before calling us. When they call us, usually they have more complex problems.
Yep, thank you. And there are a few more questions coming in. So Igor is asking, are there some common techniques to identify possible performance issues in a model?
What do you mean? I mean,
so I think I would say it's self-explanatory. So the common techniques are the ones you were talking about today.
So I would say this: it's not easy to predict that you will. I mean, I can tell you, if I open a model, if you ask me, Marco, look at this model, okay? Let me know if we could have performance issues. Oh, I always find something. I always find something. But the problem is, does it matter or not? That's the problem. So prioritize your effort for optimization is very important because we have a finite amount of time. In a finite amount of time, you have to prioritize where you want to spend your time. Not having some example of the report that you want to run makes the work complex because we don't know what to optimize. I can tell you, oh, you should do this, but the problem is that when we start to optimize, we always optimize for a report. We don't have an optimize. There is not such a thing like an absolute optimization. It simply doesn't exist. When we optimize something, we usually do that at the expense of something else. Now I shown you an example, which was a DAX error. Okay, if you make a DAX error, because filtering a table like I did, it is an error. Okay, if you learn DAX, is one of the first things that we teach is don't do that. But if you are not making a mistake in using trivial concepts in DAX, the problem could be complex. Could be that you made something that makes sense, that works, but for the model you have, the distribution of data you have, does not perform well. So I can tell you that I can locate errors, but when it comes to the data model, it's complex because maybe that the alternative to the model you produced is very expensive in terms of, for example, work or time to refresh the model, or it could optimize something but not something else. So I think that we can find bad practices, but you can find only very, very simple things. For more complex problems, is not that easy. Is not that easy, to be honest. And so, I think this, if I try to simplify the problem, you end up saying, oh, Marco said that. Now we open the model, or do this in the model, do this everywhere. No, because probably you are spending a lot of time doing something that will not produce any benefit. So when I say we have to prioritize, you have to figure out, okay, what's your model? What's your report, or what are the reports that you want to run? Make some benchmark, and then focus on where you can optimize something. Of course, otherwise I can tell you, you don't want any problem. Create simple star schemas, no exceptions, no snowflake, no bidirectional filters, no many-to-many cardinality relationships, only star schema, strict rule, no strange things, everything will be fine. But the real world, sometimes you cannot. And so, so when you can, go to the star schema. When you cannot, trade-offs.
So few more questions. So are missing keys, the existence of blank rows, relevant to the performance of a calculation?
No.
Okay, this was easy one.
I mean, the performance is not a big concern. You will find there is an article or two talking about this, but actually, in my experience, you are trying to look for a microscopic issue that almost nobody experiences. So no, usually is not an issue. Okay. It could be an issue for direct query more than imported data. For imported data, the performance is not really an issue. The issue is the correctness of the calculation. I will be more concerned about that. Did you plan for the blank row or not in your model? Did you manage the right way the calculation? This is important. But for the getting the right number is important. The performance usually is not an issue. Usually.
So one more question is, do shapes and text boxes also increase other wait times noticeable and need to be checked?
Yeah, if you, yes, exactly, absolutely. How much depends. You want the best visualization experience, remove everything that is not required. One technique used by advanced Power BI developers is that of creating a bitmap with everything that is not the the data. Okay, everything that is not the data is a bitmap. A single bitmap uses as a background, and you put the numbers on top of that. Now, the problem is that if you go to this extreme, creating the report is going to be expensive because you will spend a lot of time trying to align everything. Then if you use font, then you have to pay attention to the sides on different screens. So, try to find a balance, because if you really remove everything and you also display the titles and the labels this way, it could be hard to align the numbers, right? So be careful. But when you can reduce, you get some optimization. But usually I don't care too much about having 5 or 10 strings around. It's not a problem. But if you start having too many, if you start having, I have seen reports where you have literally hundreds of small, tiny lines and small bitmaps just to obtain a graphical effect. That is expensive, right? So try to find a balance.
So one question coming from Christian is, what's the limit in terms of number of rows when a model is considered large?
So again, it depends, but let's say if I open Vertipack Analyzer and I see something that is hundreds of million rows, okay, that's interesting. Not necessarily a problem. Having a fact table of 100 million rows is not an issue at all. Having a dimension, so any table on the one side of the relationship that is above 1 million rows is definitely a potential issue. So it depends on the role of the table. Tables on the many side of a one-to-many relationship, 10, 20, 30 millions, I don't care. 100, 200 million rows, okay, it's not a problem, but I have to pay attention. When I approach 500 million rows more, start to be large, pay attention when we touch that table, right? Because every scan of that table could take, depending on the hardware or the tier that you have in analysis services, it could take, you know, hundreds of milliseconds to seconds, right? So it starts to be expensive. Above 1 billion rows in a fact table is a large table. Above 10 billion rows, I probably don't want to have more than 10 billion rows in memory, because whatever I do, it's going to be expensive, or you need a very, very fast hardware. But with a cloud, not a good idea.
And the last question came in regards to visuals waiting for each other upon refresh, is it possible to modify or specify in which order they should be refreshed?
No. No. You don't have control over that.
So yeah, that's all of the questions. So from my side, Marco, thank you very, very much.
Nice.
And for your time and for a very interesting presentation. And thank you all for attending in a big number, and wish you all a nice evening and take some rest after this interesting session.
Okay. Thank you very much. That's been a pleasure.
Thanks, Marco. Stay healthy and goodbye from Hamburg.
Okay. Thanks, Lars. Have a good evening.